Today I want to talk to you about bone because I think it's such an interesting tissue. The thing is that most people view bone as something that they see after death. But in reality, bone is very much alive. I mean, if you think about it, all you need to do for it to repair itself is make sure that the two bones meet each other, and then the bone repairs itself. That just tells you how dynamic it is. And it is also a very, very intelligent tissue in the sense that it keeps your body upright. You know, it has a mechanical quality to it. Without it, we would be a blob on the floor. So what we want to do today is do a few experiments, the same way we would do in the lab, to test how good or strong or not so strong bone can be through experiments that we usually do in the lab. Our first experiment is called a 3-point bending. And the reason it's called 3-point bending is because you have 3 points of contact. Our first point here, our second point is here, and our third point comes from the top. Depending on the material, it will either bend or break or resist. So, as you can see, this particular brick broke, and I will tell you why in a second. We have another brick we've made, and we're going to test it in the exact same way, and we're going to see if it's a similar material or not. Let's see what happens when we try to break it. Could I get another volunteer? Right? So we're going to try it together. Okay. So if we put our feet together and we go at the same time, okay? 1, 2, 3. I think we can climb on it and see.
Okay.
So both our weights combined. No. As you could see, the second brick did not break. The first brick had pretty much cement and gravel, and the second brick had one more thing, and that one thing is this. It is a metal rod, not particularly strong, yet when you combine it with the cement and the gravel, it makes a really, really strong material. And this we equate to bone itself. What you have is the mineral fraction combined with a protein fraction called collagen. And that collagen is twisted and hyper-twisted and able to withstand the loads of everyday living.
So we're going to show you another test. It's called the drop tower, which we can see here. And we'll be putting the tin in this drop tower to test the durability and elasticity of these materials. We chose 4 materials to represent bone. So the first one is real bone. The second one is semi-decalcified bone. So you can see that it's a bit more squishy. The third one is a material that represents bone without calcium, so completely decalcified. And the fourth material represents bone without collagen, just with minerals. So let's see what these materials do when we drop the tin. First, let's look at the real bone. We'll place it at the bottom of this drop tower. And when we drop the tin, we see that the bone is still there. It didn't break, it didn't bend. Now let's try the same experiment with this semi-calcified bone. We put it at the bottom and drop the tin again. And we can see that the tin jumped. It was bouncing a bit. It means that this piece of bone, the semi-decalcified bone, is more elastic, more bendy. Now when we take the third material, which should represent totally decalcified bone, which is quite squishy, when we put it at the bottom and let the tin drop, it totally squished. It didn't jump back. It's not elastic. All right, and the last one is the bone or the material that represents bone without collagen. So we put that at the bottom and drop the tin. And now have a look. You can see that the material broke completely.
One of the reasons why bone has the mechanical properties we saw is because inside of this compact structure that we usually see when we look at bones, there is a structure that is called trabecular structure that kind of looks like a hard sponge that is able to displace the weight and make the bone both strong and viscoelastic, so capable of not getting brittle like the material we saw before. To represent the trabecular structure of the bone, we're going to use this chocolate snack that has the outside that will represent the compact bone, and then this sponge-like structure inside that represent this trabecular structure. To represent the strength of bone, we are going to use these chocolate sweets, and we place them on underneath this glass board. And we're going to start putting weight to show how much actually strength this material is. So I'm going to start adding weight to this board. As you can see, there is quite a lot of weight and it still holds. I'm gonna even increase the weight even more. There you go. So as you can see, this chocolate sweet doesn't seem particularly strong, and it's very lightweight as it is bone, but as you saw, it can actually hold a lot of weight because these 3 chocolate spheres actually hold all this weight before breaking.
I hope we gave you a flavor of why we think bone is such an interesting tissue. It is light and durable, and it withstands a lot of loads. Obviously you can break them, but you need a lot more than you would have thought. So I hope you leave this with some newfound love for bones like the one we have.